Jamb candidates, welcome to today's lesson, and we are looking at waveform. How to interpret waveform. We have to know everything, part of this waveform, all the parts of the waveform. Okay, so the waveform diagram is the appearance of wave. Okay, the waveform is the appearance of wave. Okay, waveform, waiting wave the form, how wave they move. Okay, waiting, what are the components of a wave? Okay, that's what waveform. All right, so in case you need any help, any assistance, this is my WhatsApp number. Okay, you need the file containing the most repeated questions in Jamb UTM. Send me a message. For your last minute preparation plan, you need any of my material, my lesson notes, DM me on WhatsApp. All right, so let's go straight to the point. Okay, at this point, here is what y-axis. Here is what x-axis. At this point is what, at the 0 mark of any graph, is what it represents the point of rest. So the wave is at rest, and at this point velocity is equal to 0, acceleration is equal to 0 at this point. Velocity, acceleration, everything equal to 0 at this point. Okay, so let's learn how to interpret every part of this waveform. The first we have here is knowing what wavelength is. All right, wavelength. Okay, wavelength, which is what, lambda. Okay, wavelength lambda is equal to what? Velocity. Is it frequency over velocity, or is wavelength is equal to frequency times velocity, or wavelength is equal to velocity over frequency? What is it? What is wavelength? First of all, let's understand the definition of wavelength. Okay, wavelength is what? Is the distance between two crests and trough. What is a crest? A crest is half a cycle, curved half part of circle. A trough is what? Is what? Also what? Half of a what? A cycle. Okay, so but a crest is usually up, it curves upward, but a trough usually curves downward. Okay, so looking at this waveform we have here, you can see, you can be able to find what a crest is here and what a trough is. I said a crest is what? Up curve, it curves upward. Okay, upward, like this, half a cycle curving upward is a crest. So this one is a crest. Then the one half a cycle curving downward is a trough. Okay, curving downward. All right, so looking at this place, you should know the wavelength now. So what it means that this is a crest curving upward. From here to here is a crest. Then here, from here to here is a trough. So from this one and this one makes up a wavelength. So one crest and one trough makes up one wavelength, or one trough and one crest makes up one wavelength. Another trough and another crest makes up another wavelength again. Another trough and another crest makes up another wavelength. So how many wavelengths do we have here? We have one wavelength, two wavelengths, three wavelengths. So in other words, wavelength is one circle in a waveform. Okay, one circle in a waveform. So circle, this one is half a circle, this one is half a circle. Bring them together, it becomes what? One circle. So wavelength is the distance between one circle in a waveform. So from here to here is half a circle. So from here to here is another half a circle. You bring two of them together is one circle. So calculating the distance from between one circle is from here to here, from point A to point B here is the wavelength. So from here to here is the wavelength. You know, you need these two to complete one circle. Half a circle. This one is a trough. This one is a crest. All right. So this distance is known as the what? The wavelength. The distance is known as the what? The wavelength. Okay. So we are done with wavelength. Let's now look at frequency. Okay. Frequency F. Okay. Frequency can be defined as what? The number of oscillation per second. Okay. Usually 1 over time. Okay. 1 over time or 1 over second. That be the formula. Okay. The number of oscillation per second. Some textbook will tell you the number of vibration, particle vibration per second. Some textbook can still tell you the number of cycle per second. So how many cycle per second is the frequency? So this one is dependent on time. So how many cycle? Here is half a second. Here is another half a second. So how many wavelengths per second? Okay, that is frequency. How many wavelengths per second? How many cycle? Wavelengths. This one is the distance between what? Two crests and trough. Okay, so remember, wavelength is the distance between a circle in a waveform. So how many what? How many cycles in 1 second? That's frequency. How many oscillation per second? Remember, oscillation is to and fro movement. So when it's down here, to. When it goes up, fro, to, fro, to, fro. Remember, to and fro motion can be like this. Like this. It can also be like this. Like this. Okay, it can be vertical or horizontal. So this one is the vertical to and fro movement. All right. So that's that for frequency. So the next we are looking at here is amplitude. What is amplitude? Amplitude can be defined as the maximum distance of displacement in a waveform. Okay, the maximum distance or displacement in a waveform. Maximum means what? Highest. The highest distance of displacement in a waveform. So if you look at one of these circle now, formed by the the wave, what is amplitude? Amplitude is the highest height this this wave can attain, the distance, okay, of the highest height it can attain, or the highest height it can attain. That is amplitude. So the maximum distance of displacement. What is displacement? Displacement is the distance moved in a specific direction. There's a specific direction to the movement. So here, this wave is moving towards this direction, towards the right, or is traveling towards the right. You can see direction of travel like this. Okay, towards the right. That's the direction of travel. So there is a specific direction. So the displacement, you can see that it's going like this. Okay, so you just have to pick one, and this distance from here to here, remember, amplitude is the maximum distance of displacement. So the highest distance that it can attain when moving towards the direction of travel. Okay, or when moving towards a specific direction. So starting from here now, what's the maximum distance that I can attain is here. So from here to here is the amplitude, the distance. Measure this distance from here to here is the what? Amplitude. Do we have any other thing that we have to interpret here in this waveform that we are not interpreting? Okay, so that's that for that. So like I told you, all the what, the curve below, okay, are all what? Trough. Like this one, look at them. They are all troughs. While this one, curving above, or any curve above is what? Crest. Okay, 1, 2, 3. They are all crests. That's that for waveform interpretation. Let us quickly look at the parts of a Vernier caliper before we look at how to read a Vernier caliper. The parts of a Vernier caliper and what they are used for. Okay, so a Vernier caliper is an instrument used to measure inner or outer dimensions. Okay, for example, this is my pen now. If I want to measure the diameter of this pen from the outside, I will need a Vernier caliper. The jaw of the Vernier caliper, I will put the jaw of the Vernier caliper here to measure the diameter of this pen. This one is on the outside diameter. All right, so what if I want to measure the inner diameter, like this place, inside this place, the cover of the pen, inside? How do I measure the diameter inside? I will also need a Vernier caliper to measure it. Okay, that's it. I will need a Vernier caliper to measure. So there are two jaws in a Vernier caliper, two types of jaws. Okay, we have the jaw for measuring inner diameter, like this one, and we have the one for measuring outer diameters. Okay, so the one for outer diameters is usually located below the Vernier caliper, the down part. While the one for measuring inner diameter is usually where? Usually located what? Above. Okay, up, in the day up most of the time. All right, so let's understand the part of a Vernier caliper. All right, so we have the jaw. Like I told you, I said the one with the up. Now the one where they measure inner dimension. Can you see? Jaw for measuring inner dimension. This one, this is the jaw. So you are going, this jaw is like this. You are going to put it inside the diameter, and you use this screw clamp to adjust it until it fits tightly. It fits tightly to the inner diameter of the object that you are attempting to measure its diameter. All right. So you use this screw clamp to adjust the jaws. This jaw below is the one you use in measuring the outer diameter. For example, I'll just have to put this thing like this, and I use the screw clamp to adjust until it laps tightly to this pen to prevent error. Okay, error. All right. So what error are we preventing by ensuring that it is tightly, that the jaw tightly fits to the pen? What kind of error are we trying to prevent? What kind of error? Remember the types of error: erratic error, systemic error, random error, zero error. Okay, we also have parallax error. Okay, so what error are we trying to, drop it in the comment section. Okay, I already taught errors now. Okay, types of errors. Okay, so when you are trying to, during measurement, you are trying to ensure a proper fit, you are preventing parallax error. Okay, so you are preventing parallax. Let me just tell you, because no time again, you are preventing parallax error. Error due to, looseness during measurement. Okay, that's parallax error. All right. So what is the next? We already know the function of the screw clamp, and we have two scales. We have a bigger scale, which is usually long in the middle. Okay, or in most diagram that Jamb is going to set, cartoon diagram, they will put this main scale, which is the big scale. They will put them up. It's usually big, longer. Then the Vernier scale will be below. It's usually smaller. So this one here is the Vernier scale. You can see it's small. Then the main scale is big and long, usually up. On top, usually on top the Vernier scale. That's where you have the numbering. All right. So the final part of the Vernier caliper is the stem. This is the stem, and it is used to measure depths of objects. For example, if I want to measure the depth of this pen, the cover of this pen, now I will just take the depth of the Vernier caliper and dip it inside until this place. I'll put it like this until this place laps completely with this place, this part of the Vernier caliper. Then I will now take my reading here and know the depth of the cover of this pen. That's that for that. So let's head straight into what? Let's head straight into reading the Vernier caliper and also micrometer screw gauge. How to read the Vernier caliper is very easy. It's very easy. I told you before that the scale that is bigger are usually located on top is the main scale, and the small one usually located below is the Vernier scale. Okay, so which means this one on top, which is bigger, is the main scale. The main scale. Okay, while this one below is the Vernier scale. The Vernier scale. All right. So It's the same way that you read the Vernier caliper, is the same way that you read the what? The micrometer screw gauge. Okay, it's just that you just have small difference, but I'm going to teach you what that small difference is. Observe zero error. Okay, observe zero error. This zero error, you have to observe it when reading the Vernier scale. You are going to apply the zero error rule when reading the Vernier scale. You know what zero error is now? An error during measurement that is due to the what? The zero mark. Maybe because say you don't look zero mark where. Now make that error come about. Now make that they call it zero error. Okay, you don't look where the zero mark they where. All right. If the Vernier scale is in centimeter, if the scale is in centimeter, you have to what? Centimeter. Your Vernier reading, observing zero error. Your Vernier reading, this Vernier scale, when you are reading this Vernier scale, it should be in this form. It should be in 0.0 something. Okay. Whatever you get here should be in 0.0 something. Okay. But if you are using millimeter, you are reading in millimeters. Okay. When you are reading in millimeters, whatever you get here should be in 0 points. That's it, 0 points, whatever. For example, let's say here in this Vernier scale, you read 5, for example, 5, and it's in centimeter. Okay, let's say 5 was the reading, and it's in centimeter. You are going to do what? 0.05. So you are now going to be left with 0.05. That's the reading in centimeter for what? The Vernier scale. But if you are reading in millimeter, okay, and you got 5 in your reading, so you will now write it as observing zero error. You will now write it as 0.5 millimeter. As easy as that, chicken. So let's now apply it here. Okay. So reading the Vernier caliper is very easy. Just read the main scale and read the Vernier scale. You add the two values together and you get your answer. You read main scale, read Vernier scale, you add the two values together and get your answer. Okay. So reading the main scale is very easy. We already have the figure here. We have 3 here. So we know that this mark is 3. So if you count from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, 3 points. That's 4. Okay. From 3.9 approximates to enter what? 4. Okay. And it continues the same thing. So we have to read this main scale and stop where we have the what? The 0 mark in the Vernier scale. So where do we have the 0 mark in the Vernier scale? Is here. So we are going to read this main scale and stop here. That's how we are going to get the reading of the main scale. So we are going to start. This is 3. So 0.1, 0.2, 0.3. So you can see that this 0 mark is in the middle between, between 0.3 and 0.4. So we are going to give it what? 0.35. Okay. So 3.1, 3.2, 3.3. That's 3.3 and half. So 3.35. So the reading of the main scale is equal to 3.35. Then it's time to read the Vernier scale. But before you read the Vernier scale, you have to find what? The point of what? Coincidence. Okay? Or the point of alignment. Okay? Point of coincidence. Find what? Find point of alignment. Point of alignment or coincidence. The point of alignment or coincidence is the point at which one of the, the line of the main scale aligns straight, in a straight line with that of the Vernier scale. So you have to look carefully to find it. There must be a line from the main scale that aligns, it aligns so straight with the one in the Vernier scale that makes it to form a straight line like this. So a straight line from the main scale that enters the Vernier scale. Okay, something like this, straight, no bending. So you have to find it. So if we look at this place, 0 it did not align, this one 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 did not align. Can you see this one aligns straight? You can see straight from here, straight. So we look at the rest. If we are going to see any other one, no. So this one is what? The point of what? Coincidence. Okay, this is the point of alignment. So this is where you are going to stop when you are reading your what? Your Vernier scale. At this point of coincidence, you are going to stop. So stop at the point of alignment. Okay, stop at the point of alignment or coincidence. All right. So here, that's where we are going to stop. So we are going to read from 0 mark. So this is 0, this is 1. Since we have 5 here, this means that this is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So we are going to stop at what? 5, where we have the point of what? Coincidence. If the alignment was here, we are going to stop here. 4. That's the reading will be 4. Vernier reading, Vernier scale is equal to what? 5. So remember one thing that I told you, that when reading your Vernier scale, you have to observe 0 error because we have 0 point here. Okay, and since you are reading in centimeter, we got 5. We are going to represent it in what? 0.05. Okay, but if it was millimeter, but most of the time Vernier caliper comes in what? Centimeter scale. Okay, it's micrometer screw gauge that is usually millimeter, but jamb can move anytime. So always ensure you are on guard. Okay, so 0, always look at your options. Okay, so 0.05. That's what the value is going to be. So equal to 0.05. Okay, so we add the two. 3.35 plus 0.05 to get the final reading. That will give us what? So 3.4 centimeters. Okay, so this is the final answer. So this is the reading of this what? This Vernier caliper. So go online and find questions on that Vernier caliper and, you know, test what I just taught you. Okay, test what I just taught you. We are going to treat reading micrometer screw gauge next. It's the same reading, but just only one small difference. 9D, just one small difference. So go and take on questions. Okay, so most of the time when you have when you are reading the main scale, okay, and you have point something like here that we had this point 35. Okay, sometimes Jamb will just approximate everything. They will remove this 5 and do the figure as 3.3. okay, 3.3. They will just, the rest are insignificant. They will not just add it. So if you solve, you add your reading from main scale and Vernier scale and you didn't get the answer exactly what you have there, just pick the closest answer, but ensure you read it very well. You read it properly. Okay, always ensure you read it properly. What you have to do is that first of all, read it and include the points. If you read it and include all these points, like this point 5, this 5, so with the when you include the points and you solve, you add up, the answer you got is not part of the option exactly. Then you remove this one, you remove all these small points. Really, remove this one. It's not this major point, like this 0.3 or like this 0.35. For example, we read 3.123. Okay, 3.3 something. This one here. Sometimes they will just remove this something here and just take only 3.3. Then do this one with 3.3 and check if you are going to get the answer. If you don't get the answer, that's exactly what you have in the option. All you have to do, pick the closest option and you move on immediately. Let's look at micrometer screw gauge next.